everyone, welcome to my YouTube channel. So today I'm going to talk about the anatomy of the vertebral column. Make sure you have a pen and a paper with you so that you can really understand everything because I am also going to write with you guys. Okay, so let's get started. First of all, we have a thoracic, cervical, and lumbar vertebra. In terms of cervical one, we have 7 bones here. In terms of thoracic ones, we have 12 bones here. In terms of lumbar one, we have 5 bones here. So let's write it down. So a cervical will be 7 bones, thoracic will be 12 bones, and lumbar will be 5 bones. Now we will talk about the atypical vertebra. Atypical vertebra means which are a bit different from the normal range of vertebrae. Like for example, atypical vertebra of your cervical one will be atlas and axis. So we will write it down. Atypical, atlas and axis. Let's talk about atlas now. Atlas will be this bone. This is a pretty flat bone. It have the facets. These things are called facets. It have these facets superiorly as well as in oblique form. It have a big vertebral like foramen in the middle, and on the side it have transverse foramens for the passage of vertebral artery. So let's write about atlas. Its name is because of the Greek god Atlas, who carry earth on its shoulders. So it basically carries our skull with it. So it will show your skull. It will actually carry the skull on top of it. So if, like for example, it is your atlas, it is the whole skull which it will carry. All good. Now let's go to the second vertebra. Its name is axis. Its name is axis. As you can see, it is actually attached to the atlas. Like for example, this is your atlas bone. Just an example, this is not actually bone. Okay, and it is your axis. This part, like this thing which you're actually seeing here in the green color, it is called odontoid process. It is basically like a bone which is sticking out of the atlas, which is sticking out of the axis. It will basically attach to the atlas, like which is our first bone, and helps it to move it so that we can move our whole head all together. Any doubts? Let me know in the comment section. Okay, like what else? Again, it have the a transverse foramen for the passageway of the vertebral artery. Let me show you where is the vertebral artery here. So the vertebral artery is this one. As you can see on the transverse foramen, there is a vertebral artery, a transverse mean on the side. Foramina means a hole. So it is a hole on the sides. So that's why it is called transverse foramina. All good. So the first atypical bone was atlas, which hold the skull on top of it. The second bone is axis, which have this odontoid process, which helps atlas to move and also helps our whole head to move all together. So these are two atypical bones. Let's write it down. Axis have odontoid, my spelling might be wrong, but okay, all good. Now let's talk about the normal features of a cervical vertebra. I'm taking the fourth vertebra here. So basically, a cervical vertebra, we have, we all know like it is called spinous process. This whole thing, spinous process basically means pointy surface. Anything pointy, it's called spinous spine, and a process means it's sticking out of the thing. So it is called spinous process. It is bifid. Bifid means it have two faces. As you can see here, it basically have two faces, one on the left and one on the right. All good? Then, okay, we will write it down. So, typical cervical vertebra have to have spinous process with bifid faces. All good. As I told you before, it have transverse foramina. It have transverse foramina. What else? It have facets in oblique form. Oblique face. All good. What does that mean? So basically facets are like these structure. Facets are like these things, which you can see in the green, which actually holds the other spine, hold other spine with each other. So it will basically make the intravertebral joint superiorly. So we have two intravertebral joint. One is anterior, like one is posterior. So anterior one will be body to body. So like the body will be here. That's all our like, body is. And the posterior intervertebral joint will be facet to facet. So our structure will actually align with the facets to the facets. So see, as you as you can see here anteriorly, the bodies are attaching with each other, but posteriorly, these facets these facets are actually attaching with each other. Any doubts? Let me know in the comment section. All good. Now, it also have the small body. Small body. It have the smallest body. Why? Because it have to bear least weight. Because it have to bear least weight. All good. Now we are like done with the cervical vertebra. We will be doing thoracic vertebra now. First of all, a thoracic, we have 12 bones. We have already talked about it. And it have slightly bigger, slightly bigger vertebral body. All good. I'll show you how. So as you can see here, it is it is a cervical vertebra, like because it have to bear less weight, its body is small. As we go down, as you can see, the bodies are actually going bigger, 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 bigger. And in our lumbar region, it is the like it is your like biggest body here. All good. But now let's get back to the thoracic region. All good. So in terms of a thoracic region, you will have this costal facets. in all of this in terms of this like thoracic region, you will have the coastal facets in all over the thoracic region. It basically means your ribs are going to attach with it. I'll show you how the ribs will attach to it. If you can see, ribs are actually attached to your coastal facet. Ribs basically, the second name is coastal. Ribs, coastal, same thing. All good. Now we will write it down. It has slightly bigger body and have coastal facets. It does not have transverse foramina. If you can see here, you can't see any transverse foramina here. There's no way you can see anything because there is not there. All good. But you can see the spinous process. You see the spinous process as it was of two faces here, but now it will be only of one face, but it has started to becoming bigger and bigger in size. So the body will become like bigger in size in the thoracic vertebra as compared to the cervical vertebra, and also spinous process will be longer in size as compared to the cervical vertebra. So why it is longer? Because in terms of cervical vertebra, like we can do yes and no movement. It means flexion and extension. And in terms of your thoracic vertebra, you can't just do this because it is actually dangerous for your internal organs. So what is the function of this thing is it will actually prevent it to go hyperextension as well as hyperflexion. But you can do rotation over here. Lateral rotation is happening here. Okay, we can write it down here. Long spinous process causing lateral rotation. Anything else? Any other thing you can like notice here? This pretty much, yeah, we have actually covered everything. All good. As we all know, it is 12 in number. Let's go in terms of lumbar region. Lumbar region, we have five vertebra. As you can see, it has the biggest vertebral body in as compared to the thoracic and cervical spine. We have the biggest vertebral bodies as compared to the thoracic and cranial spine. All good. Next thing, what else? It has smaller spinous process. It has smaller spinous process. So, for example, this spinous process, it is actually smaller to actually facilitate flexion and extension. So, flexion and extension will only happen in the region, not in your thoracic region. It will only happen in your like lumbar region, not in your thoracic region. In terms of your thoracic region, it will only do rotation, lateral rotation, not your like lumbar region. Good. Any doubts? Let me know in terms of the comment section. Okay, so we have already written it down. Anything else? Any other things you can see? Basically, no. All good. That is the end of today's workshop. So